Hey everybody. Today we're talking about compositions of functions. In order to compose two functions, f and g, basically you just plug one function into the other function. In order to evaluate that new function, f composed with g of x, at any point, you're going to take that value, plug it into g of x, the inside function, the second one that's written in the f circle g notation, get a result out there, and then plug it into the other function, in this case f. The domain of a composition is going to be all the values that, first of all, you can plug into g of x, the inside function, and which give you a result from g of x that you can then plug into f. So there are two conditions on the domain here. Here's a very simple example. F of x equals x squared, g of x equals 2 plus x. Let's do f composed with g of 3. So we have to do two steps here. First, we plug 3 into g. G is x plus 2, so we get 5 out there. Now we have to plug that result, 5, into f. We square it, and we get 25. Let's also write out the whole formula for f composed with g of x. What I'm doing here is taking the formula for g of x, 2 plus x, and literally plugging it in for x in the formula for f, overall 2 plus x quantity squared. In this case, the domain is going to be all real numbers. I have two polynomials. There's no number that I can't plug in here. This is a more involved example. We have two functions, f of x equals 1 over x, and g of x equals x squared minus x. We want to compute f composed with g, g composed with f, and f composed with f. In each case, we want to find the domain. Let's start with f composed with g. So, f composed with g is f of g. Here I'm taking out g of x and replacing it with its formula, f of x squared minus x. Now I'm looking at the formula of f of x, taking out the x in that formula, and replacing it with x squared minus x, like so. This is f composed with g of x. The domain of g is going to be all real numbers. No concerns there. That's a polynomial. We just need to concern ourselves with the values of x that are going to give g values that aren't in the domain of f. In short, values of x that make this denominator equal to 0. So we have to solve x squared minus x equals 0, for example, by factoring. X times x minus 1 equals 0, x equals 0, or 1. Overall, the domain of f composed with g of x is going to be all real numbers except x equals 0 and x equals 1. Now let's do g composed with f of x. This time, f is the function going first. It's going to be plugged into g. I'm doing g of 1 over x. Now I look at the formula for g of x, and wherever I see an x there, I replace it with 1 over x. So I've got 1 over x quantity squared minus 1 over x. If I like, I can simplify that a little bit to write 1 minus x over x squared. The domain of g of x is all real numbers. It's a polynomial. So the domain of g composed with f is going to be the same as the domain of f, namely all real numbers except x equals 0. Now, one thing to notice here, f composed with g and g composed with f were different. That's almost always the case. When you're composing functions, order matters a lot. Finally, let's do f composed with f of x. So I'm going to plug into f, get a number back, take that result, and plug it into f yet again. In terms of symbols, I'm doing f of 1 over x, f of f. So I go back to the formula of f, and wherever I see an x, I replace it with 1 over x. So I get 1 over 1 over x, also known as x. The domain is a little bit tricky here. It's going to be all real numbers except x equals 0. In order to be able to plug into f composed with f of x, I have to be able to plug into f, and then plug that result into f again. Long story short, when you're computing the domain of a composition, you always have to look at the unsimplified expressions, not the fully simplified expression. If I had looked at f composed with f of x equals x, I would have missed the fact that x equals 0 is not in the domain of this composition.